I have a question for you. That is, how long did it take to get through the shoe, like for the fungus?
Yeah, way too short. That's my problem. Like,
Well,
that sounds
actually,
very perfect.
actually, it would work that way, but okay. Let's get into the tangent. Uh, so, okay, we have a problem. Like, Hero has fungus on her shoe, so the fungus, now we go into the POV of the fungus, which was a very fun part, and I enjoyed it a lot. But, okay, the fungus has a problem. It has to get through, like, the hard rubber of the hazmat suit shoe, and what it does, it has this thing that's called endosymbiont, and from Wikipedia, I can say that it's like organism that lives in the cells of some organisms, and it helps the organism to produce some chemicals that the organism itself it cannot. And normally, the endosymbiont is usually used to produce some nutrients for the host. So it would produce something that the host itself cannot produce to give it food. But in this sense, it was a little bit different, and that is that the endosymbiont is like on the surface of the mushroom or of the shroom, and then the shroom, or like at least the endosymbiont, goes through this chain of chemical mutations or chemical reactions and tries to produce something that goes through the shoe, right? And it tries different things. We get explained that, okay, this would be a good antibiotic, but it doesn't work on a shoe. This would be good for like making nylon socks, but not really good for breaking down a shoe. And at one point it jumps... and that's where I have the problem. Like, it made some sense with the chemical reaction it does, and then it jumped to like fluoroantimonic acid, which is
that was insane.
First of all, that's the okay. How much information do you want? How much information? How do you have 20 minutes?
I'll try medium.
I'll try 10 minutes.
Try medium.
So let's start with the basics. What is an acid? Disclaimer. I'm not I minored in something that was slightly connected to chemistry, so I am knowledgeable enough to be fascinated by any chemical reaction, but I actually know nothing about chemistry. So basically that's my baseline. So take everything I say with a grain of salt, but actually, I've done some research on this because I wanted to say how feasible the actual burning through a rubber shoe with this super acid that it produces is, like how feasible this is. And okay, acids, they are compounds or chemicals which donate a proton or electron pair, or accept an electron pair in reactions. That's the definition. But okay, let's think about it on a very easy way. That's we all know the pH scale, right? So the pH scale.
This is like a speech presentation prepared by my
This is gonna be my TED talk on acids and superacids and the feasibility of fungi producing superacids inside their cells. It's
amazing.
Not possible. Okay, yeah. Long story short, it's not possible. So the thing is, the pH scale. We all know it's like the scale that measures, for all intents and purposes, how acidic or how basic the solution is. Of water and some other chemical, and it goes from 0 to 14, where 0 is something that's extremely acidic and 14 is something that's extremely basic, like I am for sometimes. And then like 7 is somewhere neutral, so 7 is water. And for acids we need to go down. So for example, lemon juice has a pH of 2. Gastric acid, which is inside our stomachs, has a pH of 1. So, and that's quite a lot of, that's a strong acid, actually. But there's a mucus inside our stomach that's protecting us, and that mucus gets constantly replaced by the body because it's being dissolved by the gastric acid, and that's the only thing that's protecting us from being eaten from the inside by the acid, and that has pH of 1. Yeah, and then you have sulfuric acid, or at least 98% concentrate of sulfuric acid, which is like the king of acids, has a pH value of 0.1. So extremely acidic stuff. Okay. And then there are superacids. Superacids are something that is even more acidic than sulfuric acid. And to just give you the reference, like sulfuric acid, if you get it on your skin, it starts burning very rapidly, and it basically, if you leave it there for a few minutes, you might not have a functioning arm anymore. So really serious stuff. In chemistry classes, they tell you this basically every class. But what it essentially means for superacids is that these are even stronger, and the pH scale doesn't really work for them anymore because they are too strong to be measured on this scale. At least it would not make this calculation of pH possible in a realistic way, and they would not be able to measure it in a proper way. So they have another scale that's called Hamlet acidity function, and just for this.
Wow. Didn't expect we would get this deep.
I said it's a rabbit hole. It's you're getting the full rabbit hole, and this acidity function. Let's make it simple and say that it's equivalent to the pH. It's just a way to generalize it to go even further into the negative values of pH, and the fluoroantimonic acid. Now I get to the point. Fluoroantimonic acid is.
So that's the one from the book, or that's something else?
That's what the fungus produces.
Okay.
Is having a pH or H0 of minus 31.3 versus 0.
Wow.
So minus 31.3. To put that into perspective,
some intense stuff.
From a random guy on Quora that has done the calculation, the fluoroantimonic acid, so very knowledgeable, very, very trustworthy source, but the fluoroantimonic acid is actually few quadrillion times stronger than SO4, so than sulfuric acid.
It sounds like xenomorph blood.
Yeah, okay, that's a good comparison. Basically, anything organic that this acid touches instantly becomes carbon. It instantly burns to nothing, or like to basic components. So why is this stupid? Because to be able to produce this thing inside of your cells, first of all, it would require an amazing amount of energy to produce that. You would need a lot of components, chemical components that the fungus definitely doesn't have in its surrounding.
That's exactly my biggest problem with this. Yes.
It would also require the fungus to have some protective mechanism that is protecting it from the strongest acid in the universe, in a way that it burns through the rubber shoe faster than the fluoroantimonic acid burns the mushroom. So how does that work? There's no way that works.